For the last 3 weeks, I have been eating burnt toast every single morning. And instead of actually just fixing the broken dial on my toaster, I kept buying different types of bread. I was like hoping sourdough or maybe brioche would somehow magically not scorch.
Oh, that is such a classic human workaround.
Right. I mean, you listening have probably done something totally similar, working around a broken tool instead of just fixing the tool itself. Well, looking at the technical papers and GitHub research notes we gathered for you today, it turns out that is exactly how current AI agents operate.
Yeah, they really do.
And our mission in this deep dive is to unpack a really groundbreaking system called MOSS and explore how we're finally moving past these band-aids toward agents that can actually rewrite their own core source code, which is incredibly optimistic for the future of productivity.
It really is a fascinating shift in how our technology improves.
Mhm.
Because, until now, deployed agents have been largely static. Even those marketed as self-evolving, they hit a very hard ceiling in their actual capabilities.
Wait, I want to break that down a bit because the research notes make a pretty big distinction here. What exactly is that ceiling?
Well, it really comes down to access. Previous agents were physically barred from touching their own core machinery, which we call the harness.
Right.
So they could only tweak what are called text-mutable artifacts. That basically means they could rewrite their system prompts or update their memory files, maybe change some simple instructions.
But the actual core code.
Exactly. The actual code governing how messages are routed or how the core logic is processed was completely off limits to them.
Okay, so it is kind of like trying to fix a broken car engine by rewriting the driver's manual. I mean, you can change the written instructions all you want, but if the spark plug is dead, the car just won't start. You have to actually get under the hood.
That is a perfect analogy, yes.
Yeah.
If a failure originates in that core routing logic, no amount of clever prompt tweaking is ever going to save you.
Well, speaking of getting under the hood to build better systems, if you are looking to integrate AI into your own workflows, you really should check out Embersilk.
Oh, definitely. Embersilk is great for that.
Yeah, whether you need custom automation, software development, or AI training, heading over to embersilk.com helps you uncover where agents can make a structural impact for your business or even your personal life rather than just, acting as a superficial fix.
And that structural impact is exactly what MOSS achieves through what the researchers call source-level adaptation.
Source-led adaptation, okay.
Right. MOSS literally edits the actual underlying programming language because languages like Python are Turing-complete, meaning they have the mathematical capacity to compute any solvable logic problem.
Wow, okay.
Yeah, so MOSS can write brand new code to fundamentally change its own logic, and it solves deep structural issues that a simple text prompt just cannot address.
I have to push back a little bit, though, because letting a machine edit its own live logic sounds incredibly risky. I mean, if it changes a core routing function, how does it avoid just breaking the entire system while you're trying to use it?
Oh, it is a crucial problem. And MOSS handles it by, well, never testing his guesses in the live environment.
Oh, really?
Yeah. When a user flags an error, or say a background scan catches a bug, MOSS drafts a fix and pushes it to an ephemeral trial worker.
Meaning like a temporary sandbox.
Exactly. It creates this isolated, completely disposable environment where it can safely crash.
Hmm.
Inside that sandbox, MOSS runs a strict 7-stage pipeline.
What does that pipeline actually do?
Well, it locates the issue, plans a fix, implements it, and actually executes unit tests to evaluate its own new code against the task. It only moves forward if the fix is mathematically proven to work.
Okay, so it practices in a safe room first, but the papers also mention an in-place container swap once the code is ready. Functionally, that sounds like swapping out a car's engine while you're still driving down the highway, but somehow your radio station and your climate control settings do not reset. I mean, your session data is entirely preserved.
That is exactly how it works. Once you, the user, approve the verified fix, MOSS seamlessly swaps the underlying code container, but it keeps your active memory and your data completely intact.
That is wild.
And if a system health check happens to fail right after that swap, it just automatically rolls back to the previous version. So it is incredibly safe.
Which is amazing. And the performance data we pulled on this is just striking. On the OpenClaw substrate, which is essentially a rigorous simulated testing ground used to evaluate software engineering tasks,
Yes.
MOSS autonomously boosted its success rate from 25% to over 60% in a single cycle. And no human developer even had to step in.
Which is just phenomenal. And that really brings us to the most inspiring takeaway for you to think about. If our digital tools can safely diagnose themselves and rewrite their own structural code overnight to serve us better, think about the immense cognitive load that lifts off of us.
Oh, totally.
What incredible heights of human creativity will we reach when we no longer have to spend all our time maintaining the tools we build and can simply focus on what to build next? It's a really bright future.
It really is such an optimistic leap forward for human productivity. Well, if you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.